Good morning, students. Today we are going to start a new chapter, which is thermodynamics. What is meant by thermodynamics? Thermodynamics is a branch of physics which deals with the concept of heat and temperature and their relation to energy and work. So, thermodynamics is the branch of physics deals with the concept of heat and temperature and their relation to energy and work. So, in this chapter we will learn about the laws of thermodynamics, which describes the system in terms of macroscopic variables like pressure, volume, temperature, etc. Those variables are called macroscopic variables. And we will also study about reversible and irreversible process. So, what is meant by thermal equilibrium? Thermal equilibrium. Two systems are said to be in thermal equilibrium if the temperature of the two systems are equal. If their temperatures are equal, we can call them as thermal equilibrium. Now, in thermodynamics, equilibrium means all the macroscopic variables like pressure, temperature and volume don't change with time. They should be constant. So, when I use the term macroscopic variable, you have to think the variables are pressure, temperature, volume. So, all those things remains same, all those things are not changing with time, then we can say that the system is in thermodynamical equilibrium. Now, example, consider two bodies at different temperature. One is at 30 degrees Celsius and other is at 60 degrees Celsius. So, what will happen? Heat will flow from hot body to cold body. That means from higher temperature to lower temperature till both of the bodies attain same temperature. So, heat flow will take place only till both of the bodies attain same temperature. So, this stage. So, what happens when the temperature is equal? When the temperatures are equal, then there is no heat flow between the two bodies, and such condition is known as thermal equilibrium. So, thermal equilibrium means it is the condition where there is no heat flow between the two bodies. That is called thermal equilibrium. See, in the above case, here I have just shown a hot cup of coffee and after some time it is getting cold. So, why the hot coffee is getting cold after some time? It is because the heat will flow between the hot coffee and the surroundings. There is heat flow between the hot coffee and the surroundings. And when the cup of coffee attains the same temperature as that of the surroundings, then there will be no flow of heat. Okay? So, the cup of coffee, when it is hot, the heat will flow from coffee to the surroundings. When the surrounding temperature and the temperature of the coffee, both of them becomes equal, then there is no heat flow. That means the system is in thermal equilibrium. Now, different types of equilibrium. First one is thermal equilibrium, second one is chemical equilibrium, and third one is mechanical equilibrium. Thermal equilibrium we have already studied. The temperature remains same. That is what we have shown in we have seen in the previous slides about the cup of coffee and other examples. Okay. Now I am dealing with now chemical equilibrium. Two systems are said to be in chemical equilibrium with each other if the composition of the system does not change over the time. The composition of the system does not change over the time. That means no chemical reaction should take place between the system and the surroundings. Only then the chemical composition remains same. See, for example, I am keeping some salt in a beaker, salt solution in a beaker. After some time, if the salt solution is reacting with some other solution, then the entire chemical composition is changing. Then it is not in chemical equilibrium. But if it is not reacting with any of its surroundings, then the system is in chemical equilibrium. Okay, so you just think like this, there is no chemical reaction. Now, what is meant by mechanical equilibrium? Two systems are said to be in mechanical equilibrium if the pressure of the system doesn't change with time. What is meant by pressure? Pressure of the system doesn't change with time. There is no unbalanced force acting on the system. That is the meaning. Because if I am applying a force, obviously there will be a pressure. A force will cause a change in the pressure. So what I mean is, there should not be any change in the pressure, which means there should not be any applied force, any unbalanced force. Then the system will be in mechanical equilibrium. And if the system is in mechanical equilibrium, chemical equilibrium and thermal equilibrium, we can say the system is in thermodynamic equilibrium. Okay? So for the system should be in thermodynamic equilibrium, it should contain three things. It should be in chemical equilibrium, it should be in thermal equilibrium, and it should be in mechanical equilibrium. Okay? So please take down those notes. Now, what is meant by system? What is meant by surroundings? In this entire chapter, we will be using the term system, surroundings, pressure, temperature, volume, internal energy, all those things. So first of all, you should know what all those things means. So what is meant by system? System is defined as any part of the universe enclosed by some boundary through which exchange of heat or energy takes place. Any part of the universe enclosed by a boundary, so that heat transfer, energy transfer can take place. Example, you think like this: I am keeping a coffee in a kettle and it is closed, it is enclosed. So the coffee which is enclosed in that kettle is an example for the system. Now, everything else other than the coffee which affects that is considered as the surroundings. That means if I keep this kettle here, this room will be the surroundings, because the heat transfer will depend only on the surrounding temperature. So surroundings means we don't have to consider anything outside, you have to consider the room, that is actually the surroundings. Anything that directly affects the system is called surroundings. Any part of the universe which is not the system. So you can just take down this: kettle will be the system and everything else will be the surroundings. And system and surroundings constitute the universe. Now, a system is in thermal equilibrium or not depends on the surroundings. A system is in thermal equilibrium or not. Whether it is in thermal equilibrium or it is not in thermal equilibrium, that depends on certain factors. The first thing is surroundings. Second thing is the nature of the wall dividing the system and the surroundings. So those are the two factors. The first one, surroundings. Second one, nature of the wall dividing the system and the surroundings. So I already told you, when I take the surroundings, we just take coffee on a kettle, that time I have to consider only this classroom as the surroundings. I don't have to consider the lake which is just beside here. I don't have to consider any other locality which is not directly affecting the system. I only have to consider the space which affects the system. That is what we call by surroundings. And number 2, the nature of the wall dividing the system and the surroundings. The nature of the wall dividing the system and the surroundings. So what is that? There are two types of wall: adiabatic wall and diathermic wall. Adiabatic means, the word adiabatic you can see here, if the wall is adiabatic, there will be no flow of heat between the system and the surroundings. There will be no flow of heat between the system and the surroundings. So when I say about adiabatic wall, you think like this: it is an insulating wall. Okay? Adiabatic wall means it is an insulating wall. Now, the second type of wall is diathermic. Diathermic wall, if the wall is diathermic, then the flow of heat will take place between the system and the surroundings. So it is a conducting wall. So think like this: system and surroundings can be separated by two types of walls. The first one is adiabatic wall, which is called insulating wall. So there is no flow of heat between the system and the surroundings. The second wall is called diathermic wall. In that, there will be heat transfer between the system and the surroundings. That is why we are just saying whether the system will be in thermal equilibrium or not. That depends on surroundings and the nature of the wall dividing the system and the surroundings. Okay. Now, types of system. What is meant by open system? Open system, in this system there is exchange of energy and matter. There is an exchange of matter, there is an exchange of energy. You think like this: I keep a cup of coffee in an open vessel, in an open cup, or I am just boiling the water keeping the lid open. So at this time what will happen? You can see the vapor is coming up. So vapor means actually matter. So matter is also getting transferred from the system to the surroundings. Energy is also getting transferred. So there is an exchange of energy and matter. Such kind of system is called open system. Now the second type of system is called closed system. In this system there is no exchange of matter taking place, but there is exchange of energy. So think like that: closed system means only exchange of energy is taking place, exchange of matter does not take place. So in the closed system, example, you think about a balloon, a gas balloon. So here, as the balloon goes up, the heat of this balloon can just get exchanged to the surroundings, but this gas will not be exchanged. Gas will remain there itself. Similarly, a pan with a closed lid, I am heating. So the pan with a closed lid. So heat can be transferred to the surroundings, but no matter will be transferred. No steam can go out. So that is the example for closed system. Matter transport will not take place, only energy transport will take place. And the last thing is isolated system. In isolated system, there is no matter transport and there is no energy transport. Neither matter nor the energy can be exchanged with the surroundings. So it is an isolated system. Example, I am keeping a hot coffee on a thermo flask. So in thermo flask, the tea can be kept for long hours hot, because the walls of the thermo flask are insulated and it does not allow the heat to flow out of the flask. Okay, it does not allow the heat to flow out of the flask. So that type of system is called isolated system. Okay, so that's all about this topic. Thank you.